For many real-world machine learning applications, you don't need machine learning code. I said what I said, but let me explain. You see, machine learning has many applications in industry that are not as difficult as segmenting streets all around the world with different street signs and rules. For example, there's the detection of safety measurements on construction sites, like helmets and vests. Or, and this is one of my favorites, applications in agriculture, such as detecting pests and diseases in crops or grading and sorting produce. And there's of course much more. But those companies or individuals don't really need a full team of experienced machine learning engineers or researchers to develop complex models that solve the problems I just mentioned. And if you want to build such an application for them or just for fun, you also don't need that. So you might now think to yourself, yeah, I want to build such an application and train a machine learning model, but how without any code? Well, let me introduce you to the amazing V7 tool and the concept of autoML. V7 is a tool with which you can label your own data, but up to 10 times faster by, for example, but not limited to, using their amazing auto-annotate tool. This tool can of course do much more. For example, you can have them automatically train a custom machine learning model on your own data and then have them deploy it. So let me just quickly show you how easy it is to do that and then talk a little bit about how this AutoML stuff actually works. Okay, here we can see the dataset that I have, and the one that is of interest to us is this birds dataset with 1909 images. There are different types of birds, but I only wanted to focus on those African grey parrots, right? And I did some labeling of 76 images, right? So I drew the segmentation maps, or I let the auto-annotate tool draw it for me. But in the end, the model that we want to have is one that can predict this segmentation map. Right, it's only 76 images and more would definitely be better, but it will be enough to showcase what we want to achieve here. So, we want to train a custom model. Therefore, we'll go to this Models tab, right? And you can see there are already public models that you can just deploy right away and use, but we want to train one on our own custom dataset. Therefore, we'll go to the Train a Model tab. We can already see that here are 3 model types that we can select. One is instance segmentation, one is object detection, and one is simple classification. And with instance segmentation, you'll get the most accurate results, right? You can predict the most granular information. With bounding boxes, it's really bulky, right? And with instance segmentation, you can really get every corner and every shape. And it's the best out of the 3 options. We can now just name our model like we want to. Let's call it bird segmentation V2 because I already have a V1. And now we can continue. So here we can select which dataset we want to train our model on. And as mentioned, it's this birds dataset. And we can already see that we don't have that much data to train on, and it will already tell us that we have medium-low data and that this class will perform fairly poorly. But again, it will be enough for this demonstration. So we can pretty much just continue. You can see how this model will split up the data into which percentages, right? It will do an 80-10-10 split for training, validation, and testing. And you can see how long it will run for the training. Usually it runs for about up to an hour. You will see that it costs 0.33 credits per minute, which is not that much. And that is literally it. You can train a custom model with a few clicks on this dataset that you have created. And the most important part of training such a model is the quality of your data. And with literally 1 click, we can start the training, or I guess 2 clicks. We can start the training and we'll see that it is scheduled. After about an hour, you'll get an email when it tells you that the training is done. And when the training is done, we'll be able to look at some metrics. I already ran 1 training, so let's look at the metrics that we have here. We can see how the model performs with its section over union scores, right? You see, it isn't the best model in our case. The data isn't that good, I guess. We can see some usage metrics. We'll get to that in a bit when we get to actually using the model for predicting. And we can see that here we have a loss curve, and we also have this nice section down here, which again we'll get to when doing the predictions. But we have everything we need in one spot. We have nice explanations about what precision and recall are. But how does this whole AutoML magic work? What happens behind the curtains? Well, of course, there are multiple different techniques that are applied for such a process. One, for example, is using a model that was already pre-trained on a similar general task and fine-tune it on the new one. After this video, I recommend you to watch this video right here that is linked in the info card, where I explain fine-tuning. Another technique that is already applied in research and industry is hyperparameter search. There are so many hyperparameters for a model training. How do you know which ones are the best for your specific case? Finding the right combination of the learning rate, the right dropout rate, the right number of epochs, etc. is already performed very systematically by just trying out different hyperparameter combinations along the grid. Now, this is called grid search, and of course there are multiple different approaches that are a bit more sophisticated than just increasing the learning rate step by step, then the next parameter step by step, and so on, but you get the point. Then there is cross-validation, where you just try out different splits and partitioning techniques for the data. And then there's a whole suite of different data augmentation steps and more. So you see, there are many different techniques that are pretty standard best practices, which one just needs to systematically try out. With all of that, you can build a standardized and automatic pipeline. The model architecture itself stays basically the same, but in the end, by trying out different settings for training, by tuning those knobs that we have just discussed, you end up with the best version of your model. And how does V7 in particular do this? Well, they of course can't spill all the beans, right? But they definitely also use fine-tuning, different data augmentation and optimization techniques, and in the end, they return you a model that is very good in, as mentioned, about an hour. Well, that is only granted if your dataset has enough properly distributed samples. So what is AutoML? It's the process of automatically training one or potentially multiple different models based on a standardized and optimized pipeline. And really, the most important factor that will determine the performance of your model is the quality and amount of your data. Okay, let's talk deployment and inference calls. To deploy the model, you can, again, really simply just press one button to start the model and then have them run it on their servers, and you can then access the model, have it do predictions using the simple requests API. Right, you just start the model, you can here select a few of those parameters. It will then vary the cost of your model, how it's going to be run. So nothing all too important, but we can just start our model, and then it will take some time to really boot up and start the model, and when that's done, I'll get back to you. Okay, this just took a few seconds, but you can see the model is running. You could upload an image and have it print out the output that you would receive when doing the API request, but we'll directly jump to the code for that. So the important thing is that you can just scroll down here, assign one of your API keys to this specific model that is running, and then look at the code that you need and just copy and paste. For every model that you create, you'll have a URL that you will do your requests, send your requests to. You will have your own API key that you assign down here, and it's literally that. The code is given for you, and you just have to copy paste and provide the image that you want to predict. Do it in a video stream, right, with the standard OpenCV capture loop, and we'll just look at the code live, right? So let's move this right away to the side, and we can see I've prepared the code already. We can run the imports, we can run or load the image, and we can pretty much already return the results that we want to have. So what's happening here, again, it's just the copy and pasted code from the website. This is the URL where I want to request my predictions from. I've stored my API key somewhere safe so that you don't see it, but this will just be your API key. I load the image, do the standard code that they said that I should do, and I do my request. You can now see that this request is a huge JSON file with different keys and multiple nested other dictionaries. Let's dissect this return a little bit more, and let's predict some segmentation maps. So you can see that the result returns bounding boxes. Although you have trained a segmentation model, it also returns the bounding boxes. It will return the label and the polygons. So I also just printed out the label for this one prediction that we have just requested, right? We have here sent the request to our URL with the image inside of this JSON here and the API key in the header. And we could already see that it predicted a African grey parrot. And we can see that it has only predicted one instance of this African grey parrot, right? So the length of the result is only one. And here, this is just the set of points for the polygon shape. So if we now just hide this right away, I now have this little plotting function here where I just plot the image and then iterate over all the predictions that the request returns. And then we can look at the output and we can see we here have an African grey parrot with the segmentation map, which is amazing. You here don't have a single line of machine learning code. It's literally just a request to the server which is hosting our model on V7. And we can, let's say, go for another image. Let's say image 1. I have prepared 3 images. We can look at this crazy parrot. You see the model is not perfect. It has some false positive areas here, some false negative areas here, right? It's missed out on the little legs. But what I want to show you with the third image is that it will predict multiple different segmentation maps, right? We can look at it right here. We have 19 different instances that it has predicted, or like, yeah, instances of the different maps, right? Okay, and you can see it hasn't predicted the metal right here, different parts of the parrot, I would say. It also misclassified this, I guess, towel for a parrot, but you know, that's just the model because I had 2 little images. But it's just really cool how simple it was. Just a few clicks, really the bulk of the work was creating the dataset and then just have them train a sophisticated model. And it's really simple. I will also show you how I do some predictions on a image, on a video that will pop up now. But yeah, this whole process using the V7 tool was a lot of fun and it's very easy and really everyone can do that. It's just up to your creativity and really just how you collect the data and label the data. Okay, great. If you've come so far, you're amazing and you now know how machine learning can be used in large parts of the practical industry. I myself really love machine learning research, but I also want to see this amazing technique be applied to real-world problems and make the world a better place. And the V7 tool propels this dream one massive step closer to reality. You now also know about autoML and how easy it can be to train your own custom machine learning model without a single line of machine learning code, how to deploy the model, and how to generate predictions using simple API requests. If you want to see how I train an object detection AI on a custom dataset using one line of code, then this video is up your alley. And you can definitely follow along, and that for free, by signing up to the V7 Academics program. Now it's your turn. Bye!